How you doing today? Jeff Ray, featured guest host here on Weld.com. We're back up here in the Weld.com lab. I'm going to take you through how to set up a purge. I've worked several years in the food, beverage, and pharmaceutical industry. I'm going to take you through a series of videos going through a number of processes that you'll encounter in real life scenarios in this industry. But today we're going to go through how to set up a purge. Let's get at it. So I'm going to go through some of the setups that I got in what I use to do the jobs. Over here I have a Smith Equipment dual flow meter regulator. I've used these for years now. I love them. They really regulate the bottle pressure and the flow rate. Awesome. Some people will use individual flow meters and put them on a T-block and use them on the same bottle. If you don't have a T-block, you can use two bottles and run two individual flow meters as well. I've got the green argon hose here that I use. I've got a quick connect set up on them. All my purge plugs are set up with quick connects to ensure that this doesn't just pull off of a hose barb or anything like that. Really gets a nice seal to make sure and ensure that all oxygen is out of the pipe and we don't get any oxygen impeding in there as well. I'm going to go through some of the different purge plug setups and things you can use to set up your purge, as well as things you'll encounter in real life situations that you need to know when purging tubing and pipe out. There is a process to this, and you need to know these things in order to have 100% proficiency in your welds to ensure that these field welds are made good and these bench welds are all made good. I'm going to take you through a number of different things you can utilize for purging. I'm going to show you some of my personal purge plugs that I have here with a various number of sizes and clamp connections, eye-line ferrules, tri-clamp ferrules, as well as I'm going to show you the other things you can use to set up a purge, different tapes, metals, things of that nature. So what I have here are a bunch of tri-clamp and eye-line fittings. You can see here, all my purge plugs utilize a brass muffler or diffuser. So this is going to help the argon act as a column to evacuate any oxygen out of the pipe. As opposed to, if this wasn't here, we could blow a stream of argon and actually trap oxygen within the pipe, which we don't want. So here I have a tri-clamp and eye-line fitting. Mainly you'll encounter in the process industry is tri-clamp fittings, but you also will utilize eye-line fittings as well. It's a male-female setup, so if I have a male fitting or a female fitting that I got to weld to, I can just take my tri-clamp end cap here and put it to whichever side I need to adapt to make the purge and ensure that I have a good seal on there. I utilize these Teflon gaskets that I've acquired over time because they don't burn up and I can ensure that there's no oxygen that's going to get pulled in here. As well as I have some you'll see with slits in them, and I'll take you through that later on in another video about actually back purging something when you have a dammed piece of pipe that you can't, that's not open-ended, that you can't evacuate the oxygen out of. So we have the eye-line, the tri-clamp fittings, commercial grade silicone rubber purge plugs that you can use. You can use balled up aluminum and stick it into the end of the pipe, as well as I have heat tape here. I'm going to demonstrate that here for you today and show you how this stuff is used, as well as what you're looking for in a weld. So I'm going to tell you what it means to purge pipe and why we do this. So essentially what we're trying to do is evacuate all oxygen out of the pipe to ensure no oxidation. So that entails backing the material with the argon. So we're going to need to pressurize the tubing as well as vent it to allow the oxygen to escape. I'm going to go through some real life situations and things you'll encounter and what you need to look for when doing so in prep and in your welds. So here we have a high point vent. So when you're going to purge this long run of pipe, you have a high spot in it, and the argon is going to fill up essentially from the bottom up. And if you don't have a high point vent to vent that oxygen out of, and you think you're just going to be able to vent at the end of the tubing here, you're wrong. That argon is going to fill up the low level and then just start to fill up from the low side again once it travels through the high point. So that oxygen will actually get trapped at the highest most part of the pipe. And I've encountered this in real life where my welds will become concave because I don't have the argon backing it, and that weld will actually sink in. And then you have a bad weld, you got to cut that out. So essentially what I like to do with fitting these high point vents is I'll take a file and I'll actually notch a little vent hole in it. So when the tubing is mated together, I have a vent hole, and that'll be at my highest most point to ensure that that oxygen is able to evacuate out of the pipe here, because we don't want no bad welds, especially up in the pipe rack. And like I was saying, that can cause a concave weld, which we don't want. You know there's a problem there, so we're going to have to address it. Another thing to look at is when purging this stuff, if you have too much back pressure, if your vent hole is too small or your purge flow is too high, you'll have an actual convex weld and it blows that out, and it'll look like you almost got a cap on there that you put on it. And that's not a good weld. You're going to have a spot within the pipe there that now bacteria can settle in and build up in. So that's not needed. That's not what we want. We want to cut that out, replace it, and fix it. And these are the things I'm trying to help you learn to prevent this from happening. So now we're going to go into the purge time duration. This is just a couple examples of what you'll frequently see a lot of 3-inch tubing, and it gives you a good reference point to start with to know how long you need to purge your pipe. And I'm going to show you the chart as well that's going to show you all the various sizes of tubing and how long it takes at what CFH level to evacuate the amount of volume within the pipe. So for example, at 25 CFH, we have a piece of 3-inch OD tube. At 30 seconds per foot is what it'll take to evacuate all the oxygen out there essentially. 30 seconds per foot at 25 CFH. So in a 10-foot or a 20-foot run of pipe, it would take essentially 10 minutes to purge out that amount of volume of tubing. I always like to let it go longer than that to ensure that I have a good back purge on there. 4-inch OD tube is about 60 seconds per foot. So on a 20-foot run of pipe, it would take about 20 minutes to purge out a 20-foot run of 4-inch tubing. From there, I'm going to take you through what we need to look at and quality-wise as well, making these purges and showing you what is acceptable to passing. You want a good back purge, and I'm going to show you a chart as well that'll show you the ranges of coloration on the inside of the purge that you're going to be looking for. So we're going to get a purge set up on this piece of 4-inch over here and get a weld going, and then we're going to assess it. So let's get at it. All right, I'm going to go through my machine settings, but first I'm going to show you how this torch is set up. So this is going to be what you're going to see out there in the field when working in the food, beverage, and pharmaceutical industry. You're not going to see guys using a finger switch or a foot pedal. Most of the guys run a suitcase welder, a small size welder that you're going to be utilizing. So we're going to have the machine set on a stick setting. So you take the stinger to this argon block that you can have a bolt connection up to it or just put the stinger directly to it. You won't see this in the field because there will be a boot that encapsulates the whole thing to ensure that it doesn't arc out on anything. We don't want anything happening or to get rode up. So you'll always see a boot over this. This is going to be widely used, something like I said you'll see common out in the field there. We're going to utilize the ESAB EMP 235 IC machine here. Got it set on stick. For this machine, you got to have the volts on for the lift arc to work. I'm going to be running a piece of 4-inch OD tube here. So I like to run it at about 60 amps. 3-inch and under, I'll run it about 45 amps. And 1-inch and smaller, I'll just have to fine tune it and turn it down a little bit. Now that we got the machine set up here, I'm going to go over and talk about the regulator a little bit and my flow rates in what I do when welding out a piece of pipe under purge. So come over here and show you that. So now I'm going to take you through how I have my regulator set up and all my flow rates and everything. So like I was saying, you're never going to see anyone really out in the field using a foot pedal or a finger switch. You can run the machine if it has the solenoid built into it to where it triggers the argon on the solenoid and you don't have to turn this valve on. This is what I'm used to using, so this is what I'm going to show you today. The valve here turns the gas on and off. I'm going to go ahead and set my flow rate. Usually doing this stuff in the field, you're outside, so the elements are a factor. So I like to have my argon flow set real high so none of the winds will impede and blow my arc out, and then you have oxidation in your welding. It's bad. So I'm gonna open this valve, set the flow rate on this right now. We're indoors. I'm gonna set it at about 50 CFH here, and that should be plenty enough. And then when I set a purge up, my experience, I know what size of a hole that I want to vent with out of the tubing. So when I'm purging it and I want to just evacuate the oxygen out, I'm going to set it at 25 CFH. It's a faster flow rate to help get more of it out. So time is of the essence and we want to get that oxygen out. But we don't want to mix it, so we're not going to blast it with it. We want to just steadily evacuate the oxygen out of the pipe. But when I go to weld it, like I said, the back pressure within the tubing in the hole in your flow rate is going to dictate that concave and the convex in the weld because of the back pressure that's going to build up within the tubing. So I'll usually turn it down to about 20 CFH, and that's what I like to weld at. So from there, we're going to leave this purge on, get this piece purging, and then I'm going to take you more into the things that I'm looking for when actually making a bench weld when doing this type of weld process. So we've had the purge running for a couple of minutes now. This thing should be well purged out. I just wanted to go through a couple of the different things that we utilize to cap off the end of the tubing with when purging. Like I said, I like using my clamp-on style purge plugs the best. It helps really keep that ferrule from deforming, and like I said, it ensures a good seal that I'm getting a good purge on the pipe. What I'm going to use today is the heat tape. That way we can give you a good visual of what it looks like on the inside of the tubing while it's breaking down. As well as we'll show you some of the other things you can use. You can use the commercial grade silicone rubber purge plugs. You can use aluminum foil. People will ball that stuff up and throw it in there. If you're not going to put a lot of heat to it and all you have is masking tape or painter's tape, you can utilize that as well. As well as there's a various number of styles of aluminum blocks that they use that can either get clamped on there or wedge onto the inside of the pipe. We've got this thing purging now. I'm gonna go ahead, get my hood and jacket on, and we're gonna make a weld here and assess it, and let's get at it. All right, so we've had this thing under purge for several minutes now. As you can see, I got my high point vent here to get all the oxygen out of there. We're not gonna be spinning this pipe out at all here in the bench. I'll get into spinning out pieces in the bench in another episode, but right now we're going to keep this piece of pipe stationary because you don't always get the luxury of spinning things out. It's nice sometimes where you just got to stand there and spin a piece out, but it's not always feasible. So I'm going to go through things that I do to set up to make this easier. First thing I'm going to do is when walking the cup, there's going to be a lot of movement within this TIG rig here. And this lead will play a factor in the movement, and I don't like fighting that. So what I do is I take my arm and I reach over the lead and then back behind it. That way that the lead, the weight of it is on my arm and not within the torch right here. That being said, I'm going to start at about 5 o'clock, and when I get to the other side, I'm going to tell you and show you how I tie back into this spot. So I like to sit on it there for a second, let it start to burn in, then start walking that cup. This 4-inch, you can't walk too fast on it. You got to give it enough time to break down. It's a bit thicker than your smaller diameter tubings that you'll mess around a lot with. I usually weld the 4-inch at about 60 amps, like I'd said, to ensure I get a good burn in. Just move nice steady speed. All I'm really looking for is the swirl in that puddle, as well as I'm watching the edge of my puddle. And I just watch the edges of those puddles to fall to each side. And that's how I keep a uniform weld. I don't want it real wide, I don't want it too narrow. Just be consistent. Now when I come up here onto the top side, to make my tie-in easier, I'm going to take this weld as far as I can, just to make it a little easier for me on the back half when I go to tie back into it, because sometimes you're in a confined space where you're limited on space, whether the way the pipe's orientated or the work environment. Now when I go to snap out of this here, I'm just going to tilt back on the rig a little bit and walk a little faster, and you'll watch that weld taper off. Snap out of it, you'll get a nice tail. Alright, like I said, started at about 5 o'clock here. Now to ensure that I get a penetration back on where I'd started, I'm going to overlap an inch. That gives me plenty of time to let that weld start breaking down so I don't miss a spot in there. Same thing when I get to the top side, I'm going to go past it an inch to ensure that I've overlapped them and we didn't miss any spots in there. As well as I'm going to take the stainless steel wire brush and my start and stop points, I'm going to clean those up a little bit too. All right, let's start back here about an inch overlap. Let it burn in for a second. Start moving. I'd like to give a shout out to ISO Tunes. They've supplied us with a couple of pairs of these ISO headphones. They're OSHA approved for noise canceling. I don't like listening to fans run and obnoxious pieces of machinery or pumps running when I'm out there, or just in the garage in the workspace. So I'll throw these headphones in and just jam to my music or listen to a podcast. They can help you out, give you a 10% discount with Weld 10. You go on over there, check out some IsoTunes headphones. Also, be sure when you're welding this stuff, you got your argon hoses laying around you. Be sure to not step on that thing. You do not want to stop the argon flow on the inside of the pipe here. So, coming back onto the top here, once again, getting out of this weld is going to be very important. We don't want any fish eyes in there. So as I talked about before, snapping out of this thing, you're just going to lean back on the rig a little bit and then start to walk a little faster, and you'll see that weld taper off. And then when it does, you just snap out of it. Hold that rig there for a second, help cool that spot. From what I can see here, looks like it's a good weld. Let this cool, we'll take a closer look at it. All right, so we got the weld done here. We're gonna go ahead and inspect it. Got my telescoping inspection mirror here. As a welder, this is something that you're gonna wanna have in your bucket. If you can visually inspect every weld, do so. That just gives you a better knowledge of how proficient your welds are in knowing that every time they're on point. I know down a run of pipe in the field, you might not be able to inspect that weld that's 50, 60, 100 feet, however long down the run of pipe. So you need to ensure that that weld is good, and by inspecting every weld you can, it just ensures you that you know that you made a good weld. So got my mirror here, gonna grab the flashlight, take a look at it. Nice and silver in there, really good. I like the consistency through the weld, as well as how flush it is. I don't have any concave in the weld, it's not convex at all, it's nice and flat. That tells me that my back pressure and my purge with the vent hole were pretty on point, as well as I had enough argon in there to help cool that weld at the same time. So with that being said, this is how you would set up a purge and some of the things you want to look for when doing so. Remember to hit that bell, that like and subscribe button. Thank you for watching Weld.com. We'll see you on the next one.